For this example, now instead of looking at the graph, we have the function f of x equals x squared minus 1 divided by x minus 1. This function is the rational function, as we know, as we are familiar with. And we are going to complete the table where the value x close to the value 1. You see the two set of the tables. The left-hand side, the x is 0.9, 0.99, 0.999, 0.99, and so forth. And the right side, 1 plus 1.1, 1.01, and so forth. Basically, on the left-hand side, x will be less than 1, but very close to 1. The right side, x is greater than 1, where it's very, very close to 1. Okay, we're going to complete this table. Before we complete the table, can you tell the domain of this rational function is any number but 1? Do you agree? X cannot be 1, right? Yes?
Yes.
Yep, because if you put x equals 1 in there, it's going to make it undefined. All right, so it's going to be a lot of work if you punch in the calculator one at a time. Here's the thing. It will lead us to the next section about the technique of the limit. Could you factor the numerator, please? What would we get?
You repeat the question, please?
The question is, I would like you to factor the numerator for me. X squared minus 1, what would you get if you factor them?
X plus 1, x minus 1.
Okay, thank you. So x plus 1, x minus 1. Okay, the numerator divided by x minus 1. What happens?
The x minus 1s, they
They
factor
reduce.
Yeah.
They reduce.
Yeah.
You can reduce because x cannot be 1 by the domain, right? You can reduce them. Therefore, this function will become just x plus 1 as long as x is not equal to 1. You see how the equation simplify? Okay. And on the left side of the table here, x, any number less than 1, they are not equal to 1. And the same as the right function at the right table, sorry, x not equal to 1, but we know that x is slightly greater than 1 or slightly less than 1. So instead of plugging the value in, so much work, so we just use the simplified expression that we just got. Instead of plugging in x squared minus 1 divided by x minus 1, we just use x plus 1 as the function value to complete the table. Isn't it nice? You guys okay? You guys understand what I was trying to show you here?
Yes.
Okay, that's good. All right, so instead of the whole fraction form, we just replace x in there and then add it by 1. That's it. So we get 1.9. If you want to challenge yourself, you can go ahead, plug in your calculator and do the hard way. You're gonna get the same number that I'm filling in right now. Okay. 19999. Okay, I have 6 of them and similar to 1.1. As long as these numbers not equal to 1, you can always use x plus 1 to represent this function. So 1 plus 1 plus 1. So 1.1 plus 1 is going to be 2.1, 2.01, 2.001, 2.000004501. Okay, now we complete the table. How do we use this table to make a conjecture of the value of the limit? So this is the point of the problem. We're going to use a table to see what would be the limit of x squared minus 1 over x minus 1 as x approaches 1. Can you tell me what the value approaching to? If you keep going with the table, the left group here, what do you think is going to keep going with so many nines, right? 1.9999. And this one going to be 2.0 and more 0. So that means both directions approaching to what value?
It's approaching 2.
Yes, approaching 2. So this is another way to explain the two-sided limit. So this, the left column, that means x approaching from the left side, coming from the left. And the second group is like coming from the right side of the value x equals 1. So coming from the left, coming from the right, the function value approaching to the same number, which is 2. Okay,